Hi, welcome back. This is Professor Ridge, and today's lesson is on section 8.4, Mathematical Induction. The principle of mathematical induction, we can prove an infinite sequence of statements S sub n by showing the following. So first step is going to be the basic step, which you show that S sub 1 is true. And then the second step, you show that if basically you assume that S sub k is true, and then that implies that S sub k plus 1 is true. And I'll show you a couple examples. So this is basically the outline of the proof. Let's look at example. Prove for every natural number n that 1 plus 3 plus 5 plus dot 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 plus 2n minus 1 is equal to n squared. So our proof is going to be, we want to write out S sub n. Okay, so S sub n, remember S sub n is our statement for given n. So if we do 1 plus 3, so our statement is what we're trying to prove. 1 plus 3 plus 5 plus dot 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 plus 2n minus 1 equals n squared. Now S sub 1, so basically we're going to do 1 plus, and we're going to stop at 2 times 1 minus 1, which is 1. So 1 equals 1 squared. And S sub k, now we're just going to substitute k for the n. So this is just helpful to write all this stuff out, so when we do our proof, we kind of know the direction we're going. Oops, this should be minus 1 equals k squared. So we're not really doing the proof yet, we're just kind of setting everything up. And then k plus 1 is 1 plus 3 plus 5 plus dot 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 plus. Now it's always helpful to go ahead and write the 2k minus 1 in, and then the next term, which is the k plus 1. Okay, and I'll show you in a minute why that's important. Okay, so our first step is the basic step, which you show that, hey, it works for S sub 1. So the classic example, if you read through the book and anytime you're taught about induction, is if you think of lining up dominoes. And for you to knock down all the dominoes, two things have to happen. First, you got to be able to knock down the first domino. And then the next thing that happen is the space between every domino has to be, just right. So not just right, but it has to be less than how big the domino is, so that every domino will hit the next one. And so if you knock down the first domino, then you create the chain reaction and it knocks down all the dominoes. So that's the idea. So the first step is to say, hey, we can knock down the first domino. So that's why you got to prove that S sub 1 is true. Well, that's pretty easy. Right, we want to prove S sub 1 is true. So you just verify it. Well, S sub 1 is 1 equal 1 squared, and the answer is yes. That's obvious. 1 equals 1. Okay, so that's true. And then our second step, now we got to show that you can pick any arbitrary k, and you assume that's true. Okay, so we're going to let k be any natural number, because again, we want to pick any arbitrary spot in this row of dominoes and show that if that one falls over, the next one falls over. So you're going to assume that S sub k is true, and then show, which means prove, that show that it implies that S sub k plus 1, S sub k plus 1 is true. Okay, so we're assuming S sub k is true, so 1 plus 3 plus 5 plus dot 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 plus 2k minus 1 equals k squared. And then we're going to try to prove that S sub k, that's going to imply that S S sub k plus 1 is true. Okay, so again, the reason you write out that k plus, you put in the previous term, the 1 plus 3 plus dot 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 plus 2k minus 1 plus 2k plus 1 minus 1 is this by the assumption is equal to k squared. Right? That's the inductive step there. So now what we do is we're going to do algebra on the rest of this and see if we can arrive at the k plus 1 squared. Okay, so I'm going to simplify this, and hopefully I can arrive at k plus 1 squared, and then I will show that this is true. So I'm going to distribute the 2. So that's going to be k squared plus 2k plus 1, which equals k plus 1 squared. Okay, so that proves that S sub k is true. Okay, so I'm going to write it this way. So thus, S sub k implies, that's that one-sided arrow, that S sub k plus 1. So if S sub k is true, S sub k plus 1 is true. And then by mathematical induction, we proved the original statement. Okay, so therefore, 1 plus 3 plus 5 plus dot 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 plus 2n minus 1 equals n squared for every natural n. And again, and sometimes I would write before that, I would write by mathematical induction, 1 plus 3 plus 5, so on, equals n squared for every natural number. Okay, so that's basically all you do. So you just show those 2 basic steps, and that's it. Alright, let's try another one. Use mathematical induction to prove that 1 squared plus 2 squared plus 3 squared plus dot 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 plus n squared equals n times n plus 1 times 2n plus 1 all over 6 for any natural number n. Okay, so let's just write out what S sub 1 is. I'm sorry, S sub n. Okay, which is that original statement, 1 squared plus 2 squared plus 3 squared plus dot 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 plus n squared equals n plus 1, 2n plus 1. So that's what we're trying to prove. S sub 1 would just be 1 squared equals 1, 1 plus 1, 2 times 1 plus 1 all over 6. Oops, I got that here. And S sub k would be 1 squared plus 2 squared plus 3 squared plus dot dot dot. And then S sub k plus 1 would be 1 squared plus 2 squared plus 3 squared. Now again, remember, include that S sub k statement, and then we're going to do the next one, because the induction step, we're going to assume that that equals the result of the statement we just wrote. So k plus 1 squared equals, so I already see a k, put k plus 1, k plus 1 plus 1, and then 2k plus 1 plus 1 all over 6. Okay, so our first step is show that S sub 1 is true, or prove S sub 1. Show, prove, same thing in math lingo. Alright, so S sub 1 is 1 squared. Does that equal 1? 1 plus 1, 2 times 1 plus 1 all over 6. So 1 squared is 1. And then we got 1 times 2 times 3 over 6, which that equals 1. So 1 equals 1. That's true. Okay, now our second step, this is the induction step. Okay, so we're going to assume S sub k is true and show that it implies S sub k plus 1. So we're assuming S sub k. I won't rewrite it since we wrote it up there. So I'm going to start with S sub k plus 1, which is 1 squared. You start with the left side and see if we can manipulate it algebraically to get the right side. A squared plus k plus 1 squared. Again, this is our assumption that that's going to be equal to k plus 1, 2k plus 1 over 6 plus k plus 1. Okay, so that's, by assumption. Alright, now we're going to do some algebra of this and see if we can make it look like the k plus 1, the right side of S sub k plus 1 that we wrote above. Okay, so we're going to distribute all this. Well, first, let's get common denominators. Okay, and notice that we got k plus 1 in both of these terms, so I'm going to factor that out. And then what's left is the k, 2k plus 1 plus 6k plus 1. Now, over 6. Now what I do is I'm going to, on Scratchwork, I'm going to FOIL the k, not FOIL, but multiply out, distribute the k, so that's 2k squared plus k, distribute that to k plus 1, combine all my like terms. Okay, so I end up with 2k squared plus 7k plus 6. Then I'm going to factor 2k, so I got the k plus 1, then I factor this, so I get 2k plus 3, and then k plus 4. Hang on, let me factor this. Okay, so it's k plus 2. Okay, so I did that on Scratchwork, just using the ridge method. Over 6. Now remember, look above at our statement S sub k plus 1 that we wrote above. This is what we're going for. Okay? So we got the k plus 1. K plus 2 is that middle term, so we're just going to rewrite the k plus 2 first. So we got k plus 1, k plus 2, which is the same thing as k plus 1 plus 1. That's from the last parenthesis that I wrote. And then 2k plus 3, we can rewrite 2k plus 3 just like the one above. It's 2k plus 1, because if you distribute, you get 2k plus 1 plus 2 plus 1 more will give you the 3. And so now you see that it looks exactly like above, so that tells us that S sub k is true. So that means that S sub k implies S sub k plus 1, and by mathematical induction, one squared plus 2 squared plus 3 squared plus dot 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 plus n squared equals n plus 1, 2n plus 1 over 6 for any natural number n. So we just proved it. Okay, and sometimes you see like 2 lines like that means you're done with your proof. All right, so that concludes the lesson for 8.2 or 8.4. Go to My Math Lab, complete your exercise there, and I'll see you next time.